Hello students, this is a video about questions on statistics. A student requested this video about Regents type questions for statistics on the Common Core Algebra 1 Regents. Okay, I'm going to try to do as many of these questions as possible, so here we go. Chris looked at his quiz scores for the first and second semester. Here's the first semester scores, and here are the second semester scores. And then it asks a lot of questions about whether the interquartile range is greater than the interquartile range for the second semester. So it asks also about the median, and it lastly asks about the mean in the third quartile. So the only way that I can think of to answer these types of questions is to actually find these numbers, the interquartile range, the median, the mean, and the third quartile. So one thing that you should remember from our class is that there's an easy way to find all of these pieces of data. It's using the calculator. So on my calculator, I'm going to go to the Stat menu and press Edit. Now that I'm looking at the Edit screen, I see L1, which is the X values, and L2, which is the Y values, but we're not using two different variables here. We're just using one set of variables, which is the semester 1 for right now. I'm going to input the values. We have 78 and 91 and 88. We also have 83 and 94. So in order to figure out the interquartile range, the median, the mean, and the third quartile, what we need to do is do one var stats, or one variable statistics. We go back to the stat button, we go over to calc, because we're going to calculate something, we go to one var stats. So press enter on that. It asks, are you sure you want to do this? And you go ahead and press enter one more time. This top number is the mean, 86.8. This number is the standard deviation, which is not asked for in this problem, but could be asked for in other problems. N equals 5 means that there's 5 values in that particular data set. It also gives us the 5 number summary, the minimum, the quartile 1, the median, the quartile 3, and the maximum. I've compiled all of those values into the list here. All the things that it's talking about in the problem. So in order to figure out whether the interquartile range for semester 1, which is 12, is greater than the interquartile range for semester 2, we actually have to find the second interquartile range. I'll pause the video and find those numbers. I suggest that you try to do that as well. Pause the video now and try to find those numbers. Alright, I've inputted all of the values from semester 2. I'm going to follow the same procedure. I go to Stat, Calc 1 var Statistics, and I'm looking at all the 1 var statistics right here in front of me. Look at that. I'm going to try to take all those and summarize them in the presentation here. And now that I have all these numbers to use for comparison, I can actually start substituting them in and crossing stuff off. The first one says the IQR for semester 1 is greater than the IQR for semester 2. Well, here's the IQR for semester 1. Here it is for semester 2. Semester 1 is not greater. They're the same exact thing, so we know that's not it. Median for semester 1 is bigger than median for semester 2. Here's median semester 1. Here's median semester 2. Not bigger, exactly the same size. Mean for semester 2 is bigger than mean for semester 1. Mean for semester 2 is bigger than mean for semester 1. That part's true. So I can go ahead and circle that. And let's just check the last one. The third quartile for semester 2 is bigger than the third quartile for semester 1. Semester 2, semester 1, right? Not true. So we can cross that off. On this type of question, all you need to do is actually find the numbers and then compare. For this next question, it asks us a very similar thing. It just asks us about the median and the mean and the salary range and et cetera and so forth. I'm going to let you pause the video now, and I'll show you the answer. Alright, I did not use the calculator to find most of these. It was pretty easy to find the salary range and the mean ages for the workers and also the mean salaries. So we can go through and check using the information we have. The median salaries are greater than $37,000. Well, that's not true because we got a $33,000 right here. So that's not true. The mean salary in company 1 is bigger than the mean salary in company 2. Mean salary in company 1, not bigger than mean salary in company 2, so we can cross that one off as well. Salary range in 2 is bigger than salary range in 1. Looks like we have a winner. And just to check to make sure we did it right, the mean age of workers at Company 1 is greater than, oh, well, no, they're exactly the same. So that's not it either. All right, so finding the values is actually fairly straightforward, and it takes you a little bit of time, but again, you have 3 hours for 37 questions, so stop complaining about time already. Let's see. Another fairly straightforward type of question is by looking at a box and whisker diagram and determining facts. For example, this one asks which destination has a median temperature that is above 80. And we're also looking for a small interquartile range. So we can go through and look at all of these locations and eliminate the ones that don't have those restrictions. Median temperature above 80. Well, looks like Ocean Beach's median temperature is here, and that's not above 80, so we can cross off Ocean Beach. Serene Shores also has a median temperature below 80, so we can cross off Serene Shores. Of the two that are left, Whispering Palms and Pelican Beach, we're looking for the smallest interquartile range. It seems to make sense that Pelican Beach has this little tiny area here. That interquartile range is much smaller than the interquartile range represented here. I didn't even get the whole thing in the oval. So that means that Pelican Beach is going to be our correct answer. It's got a small interquartile range and a median temperature that is above 80 degrees. I'm not going to go over this question because it's very similar to the previous questions. You just need to find the correct values, mean, standard deviation, etc. using your calculator and then compare them. This question asks about a school newspaper which surveyed the student body for an article about club membership. It says if there are 180 students in 9th grade, what percentage of the 9th graders, so what percentage is the question that is asking for? We're looking for the percentage of 9th graders that belong to more than one club. So let's take a look at the actual situation. In this actual situation, we have 180 students in 9th grade, but we don't have 180 students that responded to the survey. Looks like it's 90 plus 12 is 102, plus 33 is 135 students that responded to the survey. So 135 students. And of those 135 students, we have 33 that belong to 2 clubs, and 12 that belong to 3 or more clubs. So 33 and 12 is, looks like it's 45. So 45 out of the 135 students that were surveyed belong to more than one club. Try to fix this up a little bit. So that's a fraction. Now that fraction should be a good proportion for the entire student body. So we can say that that proportion is going to be equal to a very analogous proportion, the proportion of students from the entire student body, which is 180. The number of students that belong to two or more groups, we don't know. So we're going to use the value of x. And if you know how to solve proportions, all you need to do now is cross multiply. We're going to multiply 45 times 180, 135 times x, and then we're going to solve that equation. So I just showed the cross multiplication here. 45 times 180 is equal to 135x. 8100 is what you get when you multiply 45 times 180. That's equal to 135x, and now we'll divide both sides by 135. We get 60 is equal to x. So what percentage of the 9th grade students belong to more than one club? Well, 60 of the students belong to 60 out of a possible 180 belong to more than one club. So if I want to change this into a percentage, I'm going to do 60 divided by 180, and that's equal to 1/3, which is 1 divided by 3. And if you get it on the calculator, it's 0.3 repeating. If I'm looking for a percentage, I got 33.3 repeating percent. And I'm going to represent the fact that it is repeating by putting a little bar over it. Oh, that shouldn't be an arrow. How do I change that? Boom. Okay. Seems pretty straightforward to me. Alright, next question. Robin collected data on the number of hours she watched television on Sunday through Thursday for a period of 3 weeks. All of these data are talking about the same exact thing, the number of hours that she watched television. So it's not like 3 different data sets, they're all one big data set. So what we're going to do is we're going to take all this data, put it into the calculator under L1, and find the 5-number summary, because what our objective is to construct a box plot. And in order to construct a box plot, we need the 5-number summary. We need the minimum. We need the quartile 1. We need the median. We need the quartile 3. And last but not least, we need the maximum. You might want to pause the video now, and I will show you the correct answers in a moment. Alright, a moment's passed. Here's my calculator with all the data inputted. We go again to stat calc 1-bar statistics, and we can see a number of different pieces of information, but the important information are the minimum, the quartile 1, the median, the third quartile, and the maximum. So what I'm going to do, I'm going to set up my number line. It looks like these numbers are actually going to work out pretty nicely. 1, 2, 3, 4, 5. So I'm going to label my number line with the numbers 1 through 5. And sometimes I like to spread them out a little bit more, but for the purposes of this, it's totally fine to just label what you have, starting with 1. And now, for my box plot, I'm going to draw 5 vertical lines to represent the 5 important values. 1, 2, 3, 4, all perfect vertical lines, as you can see. I've done this a million times. Very good artist here. Box plot means we're going to take the middle 3 lines and connect them into a box. And the last 2 become the whiskers. Done. So now this very, very neat box plot shows all the numbers in the 5-number summary. Here we have a new problem dealing with carbohydrates and calories. It's giving us X and Y values, so we're no longer going to be able to use the 1-var stats menu. We're going to have to use something else. We have these 2 sets of numbers, so we're going to put them into the stat menu of our calculator. But if you notice, if you go into stat edit, you have a bunch of numbers in here. So one quick way of clearing out a set of numbers is by going to the top, highlighting L1 or L2 or whatever it is, pressing clear, and then pressing enter. Now L1 is completely clear. We can input the numbers by using our brain. And notice that in this case, I'm going to be inputting X values, but I'm also going to be inputting Y values. We're looking for the relationship between the X and the Y values here. And once I'm done inputting all of the data, I'm going to be able to use my statistical features to try to figure out the answer to the question. And if you'll look at the question, it's asking about which equation best represents the line of best fit. Line of best fit should make you think of linear regression. So I'll underline line of best fit. This piece is talking about linear regression. And you know how to do that on your calculator, and if you don't, you've come to the right video. Press stat. Go to calc, because we're going to calculate something. We're looking for linear regression, which is abbreviated in the calculator, linreg. Press enter on that. And once we press enter one more time, we should be able to see the important values. Y equals ax plus b, and the a value is here, that's our slope. The b value is here, that's our y-intercept. So our equation should look like this. It should look like y equals ax, so 14.11 x plus b, which is 5.83. It seems to me that none of those is exactly here, but it says which equation best represents it. So the closest match. Looks like the closest match is a no-brainer. It's the only one that looks similar to it. So we've just used linear regression on a sample problem. Alright, I wanted to show one more type of problem before I end the video, and it's a problem on residual plots. One thing that they're going to ask you about on the Common Core Algebra Regents is to analyze residual plots. These are all residual plots, and the question states which scatter plot indicates the best linear fit. So a linear fit means the residuals don't show a pattern. In this case, I can see a pattern in the residuals, a curved pattern. In this case, I can see a curved pattern here. In this case, I can see a curved pattern. A very good residual plot will show no pattern at all. See, there's no curve to it. So a good residual plot will have no pattern. Again, this was a series of questions on statistics for the Common Core Algebra test. Good luck studying.